Okay, I'm back. So we first reverse the matrix and then we do the swap where a row becomes symmetry. Okay, so this one, but when you do this, are you doing the same? This is a trick. This is something that this is this logical? Okay, let's implement it. That's the reverse. Okay, the matrix is reverse. Nice trick, by the way. Okay. So 789 is now 789. So when you swap rows and calls, you only touch you swap this row for this call, you only touch this row. You don't do nothing weird, you just do tan tan tan. This one, so this. Yeah, but when you do the second one, you do. Eight, five, six. 8, 5, 6. It just looks like some data is lost. Apparently, look, doing it like this doesn't work. Doesn't work. Nine, 6, 3. Let's see. Oh, from she's jumping. That's why it does not interfere. It's like that. I'm moving the matrix to matrix. You will be proud. This one, the Okay, why does that work? I shuffle it backwards. Then I change rows for calls. I get the image and I turn it around and I flip it. And then I don't do this row, I do the next one. So what I have done here, I don't interfere with that. That makes sense. It's more of a trick, more something you learn. It's not protect image in place.
Question: would you build a website for a major brand with more than 200 million users?
Hey, what's up guys? Nick White here. I do tech and coding stuff on Twitch and YouTube. Check the description for all my information. You can, I post a bunch of stuff on my Patreon if you want to, I'm having a tough time talking. Support me or I think it's like the best 2D array problem, like medium level, give you a great understanding about 2D arrays. But yeah, let's do it. So you're given an n by n 2D matrix, meaning 3. What does that mean? So I would just say, imagine picking this 2D array up and just rotating it clockwise. And like you would see, like if you just pick it up and rotate it, like you would see the top is gonna, you can see it's gonna come and it's gonna become the right side, and then the right side's gonna go to the bottom. All the sides like shift over one. So you know what I mean? Like the right goes. You guys know what a clockwise rotation is, so 1, 2, 3 becomes the last column. Whatever I was just saying. Also, 7, 8, 9 is going to become the left. 3, 6, 9 is going to become the bottom. But yeah, so we just want to do that. We just want to rotate it, and there's a strategy to do this. I would say check out the video transpose matrix. I think I did that one before because that's a technique we'll use here. One more thing to note is before we do this, you have to rotate an image in place, which means you have to modify the input 2D array directly. Do not allocate another array for the rotation. So we're not using extra space. This is a void method, meaning we don't have external data structures. We're not returning anything. We want constant space solution. And if we want to go through the example really quick, right? Like I said, you're taking the first row becomes the last column, basically. And the last row becomes the first.
Okay, but why?
Just look. If you wanted to do bops, it's I think it's like some guy named Lucky. Regularly you loop like this, right? You go 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you wanted to do 1, you would, what do you swap with the last element, but then the 3 is over there. You want the 3 on the bottom. So it is kind of tricky when you first think of it. But if you do it in 2 steps, it's a lot easier. Because what we'll actually do is, I think I can paste this. There we go. I wrote this out, and then I found this in the discussion. I think it's like really useful to explain this. So this is in the discussion. I think it's like some guy named Lucky Idiot or something like that. So shout out to you, Lucky Idiot. But the idea is to transpose the matrix. Check out another video where I explain this. But basically what you're doing is you're looping through, and you can see what's happening is you're swapping. The diagonals stay the same, but you're doing a like symmetrical swap on the diagonals pretty much. So you see 2 and 4 here become 4 and 2. 3 and 7 get swapped to 7 and 3. You could see 6 and 8 get swapped to 8 and 6, and that's it. And then once you have that, basically what this is doing is it's taking the rows and turning them into columns. It's not making the first row the last column, which is what we want, but it's making the first row the first column, second row second column, third row third column. And that's going to help us because once we're in this form, it is pretty easy to go to this form because what we just want to do at this point is just, okay, we'll loop through each row, 147, and we'll have a pointer at the beginning of the row and the pointer at the end of the row, column-wise, and we'll just go towards the middle, like a two-pointer approach, and just swap values. So you swap the 1 and the 7, you get the 7 and the 1, the 2 and the 8 and the 2, the 9 and the 3, 3 and the 9. So what you just do it in 2 steps, and then what happens is you do get this thing where you got the first row, you get that rotation. It's just about making the rows into columns and then kind of reversing the column order using a two-pointer approach. So that's the idea here. Let's write it out, and then I'll trace through it for you guys really quick. I wrote this trace out right before just so you understand. So I'm going to grab the length of the array because it's the number of rows and columns. So we're going to be looping. Always a lot of loops in 2D array problems, so I would suggest making a variable for the length. I. And so we're going to do a temp variable. So we'll explain that right now. And then because we lose reference to I of j, because we set it, we change trains. Our example for like the position, and you set that two-pointer approach I was talking about. The rows we're still going to loop through as we go inwards, halfway, and then we just set a temp to the current element. We do.
It's solving it differently. It's kind of cool, kind of cool. Yeah, it's just a spell. But it's solving it differently. Dimensions. Do data drive. Okay, it's not like a normal solution that everybody does. It's a different solution. Okay, so needs to
Sí.
work the code.
Ahorita ilustraremos un poquito el detalle.
Now, let's test it. Okay, so 3 1 4 2 1 1 15 2 1. Okay, 20,000 doesn't matter. Create the matrix. It's an array of arrays. Funny. So I for I I don't know why print is not printing. It's not printing pretty. Well. That's cool. Preprint's not really working, but it's cool. Okay. I need to think about that one more. It's going to be quite fast actually. Basta. Doesn't make sense. Printing it here, and it's just the same. Just doing the first step. Going over here, just here. The fuck is wrong with this? Just something weird. Oh, maybe I cannot do that. Can I test it? And for 1 and for 6. So like that. And 1, 15, 13. So that's correct. Let's test that one more time. Okay. Yeah. Okay, so let's check out the solutions. So he's doing the trick of that guy. Go ahead, like that. Okay, that's cool. Five minutes. Okay. I need to go to restroom. I will be. I think that's all for today. It's possible. So I will put the video of the guy that is explaining this one in the description, and you can watch. So thank you for